Welcome back to another episode of Hands-on SAP Devs. We're continuing our series now, picking up after a little 1-week break where we did a special video on deploying cloud application programming model applications to the managed Kyma runtime in the SAP Cloud Platform. There was an opportunity there to both promote the fact that the new Kyma trial is available, and we had the Kyma week and Devtoberfest. It seemed like an obvious time to inject that, though it meant taking a little break from our regular series. But welcome back. We'll continue pretty much where we left off. Got the same application ready to go here. We'll do a little recap. I'll show you where we were, because it's very likely that everybody kind of lost their place a little bit, being away 2 weeks. But then we'll get right back into things and continue to add custom service handlers to our CAP service. So let's dive back into the application. We'll run it and we'll see exactly where we left off last time and then continue with development. Here we are. We're back in our project in the SAP Business Application Studio. And if you remember where we left off, well, then you have better memory than I do. I had to refresh my memory, but we have built, we're largely done building the database layer. We have all the database artifacts and views. Our CAP modeling is all pretty much done. We'd moved on to the service layer, which, we started off by simply service enabling many of our entities and views. That was a couple weeks ago. But then we quickly got into how can we do more advanced things like adjust the bootstrap of the cloud application programming model itself, and how can we add our own custom exit handlers for the cloud application programming model entities and their processing. And we did leave things where we used the bootstrap to both inject the OData v2 proxy, so we'd have both OData v2 and OData v4 support for our CAP entities. But where we were really going with this is to be able to inject our own custom logic into the CAP service that did not have to be modeled in CAP or implemented via these exit handlers. So we can do our own logic, our own custom REST endpoints, or we can add WebSocket functionality or other communication protocols that maybe Cloud Application Programming Model itself doesn't cover. And we can do this all within a single service. And we had started doing that. If we go back to our server.js, which is where we took over the bootstrapping of the Cloud Application Programming Model, we can see that we branched over to our own logic here in this express.js to be able to do most of the Express initialization and configuration. And inside there, we did go ahead and inject things like the health checks and the overload protection and the little status monitor. But so far, we're kind of just attaching third-party modules into Express, or we did do some configuration like loading the HANA client library as middleware into Express and add our own logging into Express, but we're just sort of attaching things in. We want to now go a step further here, and what I want to do is I want to go here to my server, and what we want to do now, I'm actually going to go back to the server.js, and down after we do our base initialization of Express, and we add our OData v2 and REST CAP handlers, we want to begin to add our own handlers in here that are completely separate from the Cloud Application Programming Model. And what I'm going to do is I'm going to do something pretty similar to like when we loaded the server Express.js, where I'm going to see if a file exists, and if it does, then I'm going to go ahead and require it to like dynamically load it into the processing of my service. And what I'm going to do here is I'm first going to look for for anything in the folder routes with a file extension of JS. And anything that it finds there, it's going to go ahead and load this. Now I'm gonna add this logic, and then I'm gonna go ahead and restart the service. So I'm just gonna do a npm start. No, I'm not gonna do an npm start. What folder am I in? I'm just gonna do cds serve, and the path argument must be of type string. Oh, I've got undefined. I don't want, sorry, I've cutting and pasting from another place, and I've used a slightly different project structure when I've done this example. So we're going to use global base instead there to get our routes. And I think glob is not defined. Also, once again, a little cut and paste error. Let me get the glob module. And if it works this time, it worked. And what I wanted to show you, I didn't do so well since I had errors where I pulled it from. I wanted to show you that even though we added this logic and we have no routes folder, that it didn't throw an error, which if I had cut and pasted it all right over correctly would have been the case. I just, like I said, pulling from sample code from a slightly different project structure. But what we've done now, our service works. We can still come over here and run it. And yes, we see our endpoints for our master data service and PO service. And we can still run some of those other things that we added in here, like the status monitor. It's all running fine. But we also now have this logic to look in this routes folder. But it didn't break our service, even though there is no routes folder yet. This allows us to very easily add custom Express route handlers just by putting any file in a folder named routes with a JavaScript extension. It'd be picked up and processed automatically. And maybe to prove to you here, let's go ahead and do this. I'm going to put a very simple route handler in here, and I'm going to name it REST EX1 is what I'm going to name it. Right now it says cannot get REST EX1. I have not implemented that yet. But let's now create a folder in SRV called routes. And inside this routes folder, let's create a new file. Let's just call this ex1.js. And we are going to do just the bare minimum here. We're going to get the app passed into us. We can see that when we require the whatever the file is, we pass in the app, which is our instance of Express. And actually, we want to pass in the HTTP server here as well, but that's not defined. So we're going to need that a little bit later. Actually, here we are. Let's move that logic down. So we'll have the HTTP server. We'll need that for our WebSockets later, that WebSockets example that we want to attach in here. But let's now come back over here. So I showed you how we pass in app, which is our instance of Express. And then we can simply attach a new handler here. So we're saying we want this to be an HTTP GET. And it should respond to the path REST EX1. We get the request response object. Very simple. We're going to start just with a hard-coded response of hello world Node.js. And assuming I didn't mess anything up, adjusting this, we'll go ahead and restart our service. And running on port 4004. And now when we refresh REST EX1, now I get hello world Node.js. So I have, with just a few lines of code, and by putting it in a certain folder, I have added my own custom RESTful endpoint to my CAP service, not having to create a separate service, but I'm mixing this in with the CAP service. Of course, if I go back to the main CAP exploration page, it doesn't know about this service, so it's not presented here in the Welcome to CDS Services. I haven't modeled it in the at the CAP layer. I haven't had to implement it with a CAP extension handler. It's kind of like something separate than what I'm doing, but running within the same technical service. And it just does allow me to further enhance the single endpoint with my own custom handlers. So we've added this custom handler now that just is basically a hello world. But we've seen how it's not integrated in the cloud application programming model, so it's not presented in the little test page that shows us all the endpoints and lets us quickly navigate to them. Wouldn't it be nice if we had a little something that would let us test these other endpoints as well? That's the next thing we're going to add to our application. So what I've done here, I've done some of the typing while the video is paused, is I've just put in our main Express startup script here. I've added another library, Swagger, and I'm going to pass Express into it and start it up. So most of the processing here in this Swagger handler. And what I'm going to do is I'm using a third-party module here, Swagger JSDoc, that will read, once again, all the files in our routes folder, and it's looking for JavaScript documentation in a certain format, and it will use that to determine the specification of our REST APIs. This is a good way to document your REST APIs as well. And you might have noticed this little comment block that I had here before the actual handler. Well, the @Swagger is telling it that this is the special JavaScript documentation to pick up and use as its processing. We've given it our URL path, the HTTP verb type that we want to use. We've given a little summary and what responses to expect. And this is enough to build a documentation page around our custom REST endpoints and even a test tool. All we need to do is expose a Swagger endpoint. So I've just created another route in Express, and I've said app get API docs.json. When you get the JSON document, it will return all these rendered JavaScript documentations that have been processed by this Swagger JSDoc. What it's going to do is just create a JSON specification out of that in it was originally a Swagger specification, but we're actually using version 3, so this is technically Open API specification. And we'll look at what that looks like in a second. But then we're also going to run the entire Swagger UI. Swagger UI Express is available as a Node.js module as well. And it's going to give us a whole nice test frame UI for whatever documents that we have here. So let's go ahead and rerun our service. So just doing a CDS serve again. And give it a second to start up. And there we are, opening another tab. Still have our CDS services endpoint. Now when I tack on API docs.json, what we see here is a JSON document with our specification of our REST endpoints. We only have the one so far because we've only added one to our Express instance. But this is enough documentation that now when we go to what did we hang that under? We just said /API docs. That's going to be our full Swagger API website. And when I go there, it's a nice little UI that shows me all of my endpoints. and even lets me test them and test non-get endpoints as well, as we'll see later. So put and post, delete, very useful tool, very similar to like using a third-party tool like Postman to do those sort of things. Now we can do it all from a web UI, and I can say try it out. No input parameters, otherwise I could fill those in. I say execute. It performs the command. We see the response body. We see the headers. We can even download the body. So a great way to both document and test your pure REST APIs. And all you have to do is add a little bit of JSDoc documentation before each handler endpoint. And then you get this great tool, and we'll use this to test the rest of our REST endpoints that we're going to do here today. So now let's add some more interesting REST endpoints here. Our exercise 1 just had a basic hello world. Let's see some more complex examples. First of all, let's connect to the HANA database. And in this first example, I'm going to use the pure HANA client, and I'm going to read the connection parameters from the environment again, and I'm going to pass those into the HANA client, and then I'm going to do a simple select session user, current user from dummy. So this shows you, connecting to the database, but not going once again through the cloud application programming model layer, but going directly to the database would allow us to call other native HANA database artifacts or perform SQL queries directly against the HANA database. And I tell you what, as we go along here, we're going to look at a couple different examples in code. What we can do is we can just go ahead and test them right after we look at them, rather than look at a bunch of code and then come back and test it at the end. So let's come over here and go to API docs. And that's going to be REST ex2. And notice all these endpoints that I've added, simply because all of them have a little comment block at the beginning of them, are all now available in the Swagger UI. I didn't have to build anything, copy anything, document anywhere else. It's looking at all the files in that folder and looking for that certain type of documentation, and then we're good to go. But if we go ahead and execute this ex2, here we are, connected to HANA, performed the query, got back the session user current schema. And that was exactly what we asked for here, select session user current schema. Now, one of the other things that we can do, because we are running as a middleware in Express, and if we go back to when we started up Express, you see that we already loaded the environment and we connected to the HANA database. We actually told Express to use HANA as a middleware, the HANA client library, the hdbext, as a middleware. And what that allows Express to do is manage our connection pool to the HANA database. So it will keep a pool of multiple connections to the HANA database, and every time a request comes in, it will automatically pull a connection out of the database and attach it to the request object for us. And then when we send our response back to Express, it will return that connection to the pool. We don't have to worry about creating the pool, managing the pool, or even, as I did here in this first example, I had to look up the connection information to HANA. I had to pass it into the client library myself. Then I had to create a client connection, and only then could I issue my statement. But it's so much easier here with Express because we actually already have a connection to the database established for us. And it's just put here on the request object. Request.db is going to use that HANA middleware and give you access to a HANA database connection. So then with this already established connection, I can simply prepare a statement and then execute that statement, and I'll get the results back. Now, this is using the normal approach, which uses callbacks in Node.js, because this is all happening asynchronous. But we wouldn't want to, say, execute a statement before it's prepared, before it's finished being prepared. We need to make sure that things happen in the correct order here. So it's only once the statement is prepared, then we get a callback function, assuming that there was no error, and then we can execute the statement. And the same thing here. The results don't come back directly in an equals statement. I don't say execute and get the results back. It's all asynchronous, non-blocking. So our application go on serving other requests while it waits on the HANA database to perform that query. And only when the results come back will this callback handler that I've inlined here, but that doesn't matter. It's going to be called asynchronously when the query is done, and the results will be passed back in the response object. So that's what's happening here. We can go ahead and run it. You're not going to see any difference on the surface here between running these two different queries, the same query two different ways. The results are the same. I don't think, unless we would really test down to the microsecond, that we would see much difference in runtime. But obviously your coding is much simpler here because I'm not having to deal with this whole block of code. It's already being done for us by the middleware, and we get access to it with that single line of code. If we continue on, I'm not going to go through every example here. Of course, all the source code is in GitHub. You're welcome to study it. But what we've done here is we're now using the idea of promises. And what promises allows us to do is get away from quite as much of the embedded callback handlers, and instead test for a promise to see if the asynchronous operation is finished yet. So when we do the prepare statement, we just have a then that will go right into the processing for when it's done. And what we see here is we have a catch for the error. Unlike our logic here, where we had to, in each callback handler, we had to handle the error and then the results, check if the error was not initial. If it is, then process it. Here, the code is definitely ordered in a more, I think, readable fashion, but it's also setting us up with the use of promises for something even nicer, which is the await command. And what we have here is we can still take advantage of Node.js's asynchronous non-blocking constructs, but instead of nesting the callback handlers, what we can use is just the await statement. And then instead of having then catches or embedded callback handlers, the results will come immediately back into another variable, as we see here. So when you read this reads much more like synchronous straight line code execution, but it's still, we haven't broken the asynchronous nature of Node.js. We're simply writing this in a much more human readable fashion than what we have here with all the callback handlers and the nesting and the order, and the if checks inside here. We have a single error condition here, a single try catch block that goes around all these asynchronous operations. So even that's better than a promise where we had to have a catch for each level of the asynchronous operations. Here with an async await construct, we only have a single catch statement, and a single try block can catch them all. And like I said, much easier to read and understand the flow of the logic since it reads just like synchronous code. Calling stored procedures. This is another interesting operation, a little different than executing a HANA query, since we do have to load the procedure. This will go get the definition of the procedure from the database, and then it basically gives us a JavaScript function to act as a proxy for that stored procedure. And then we call this proxy function, SP, in my example, that's just what I named it. You can name it whatever you want. And what you have to do is you have to pass it any input parameters in a single array. This particular one had no input parameters. And then the callback will receive any errors any output scalar parameters as a single array, and any table parameters as an array of arrays as well. So a single results object that could have multiple tables converted to JSON inside of them. So that's a nice thing about the HDBext module. It makes it very easy to call stored procedures from Node.js and perform queries. But it also transforms everything into JSON automatically. All this results that we're getting, we're able to just put that into the response body. In all these examples, we're able to just put it directly in the response body because the client libraries are already converting the result set that comes back from the SQL client into JSON. And we can go ahead and try this one. We can call our procedure here. Just go ahead and try that out. And there we are. Store procedure. Only returned a single table. Didn't have any input parameters. But there are our results. Now, this will get a little bit more interesting. Let's see how we can handle an input parameter. To have an input parameter, all we have to do in Express is give it our path. And the last part here, we've said colon partner role. We're saying that is going to be an input parameter. We put a question mark on the end to say it is an optional input parameter. And now we can check for that. In request params will contain any input parameters. We can have multiple as well. And because it's optional, I have to check to see if maybe it's undefined or null, in which case I'll pass no input parameters into the stored procedure. If it does have a value in it, then I will put it into JSON with the name of the SQL script stored procedure parameter as the attribute of this JSON, and then I will pass that into the stored procedure. As far as our client testing, we do the same thing. We put the URL parameter as part of the URL path. We define the parameter here in a little block of text. We can even give it a description. We can give a data type so it'll be validated by the test tool. And if we go ahead and test this one, you see now we have partner role as an input parameter. When we say try it out, I think, even if I put text in there, it doesn't even try to send the request to the back end because it's validating it on the client side in the test tool, saying that the value must be an integer. So let's change that to 1, execute, and it calls the stored procedure, and we're only seeing partners with a partner role type of 1. We can change this to 2, and now we're seeing a different set of partners. And I don't think 3 is valid, so it returns no records matching that. Once again, I'm going to skip down. I've got a lot of examples in here, how to call stored procedures in parallel, how to interact with the security context, all kinds of good stuff, calling a view, just different examples of common scenarios that you might hit. We can even interact with the operating system as well. Let's go test that one. That one's pretty interesting. So we'll come down here to OS. We'll try that out. We'll execute. And we're seeing the operating system of the Linux shell that this is running inside of. Remember, we're just running cap inside this Linux shell of the Business Application Studio. So that's exactly the OS information that we got back. But you can see here we got real low-level access to the environment. That's another good reason to maybe break out of cap if you want to do some of that lower-level stuff, interact with the OS, the file system. You can do all kinds of things here with your own custom handlers and Node.js. And with that, that's about all we have time for in today's episode. I said I'd try to do better about trying to keep the episodes to about 30 minutes instead of the full hour, make them a little easier to digest in smaller chunks. We're at a really good stopping point. We've seen how we can add our own custom handlers. We've seen some of the good use cases of why we might want to use a custom handler, to interact directly with HANA. access HANA native artifacts that aren't surfaced through the cloud application programming model, access the OS. We'll see in the next episode how we can begin to use this also to maybe do a file download or WebSockets. So other media types and or response body types that the cloud application programming model does not support yet. We can further augment our service directly via these custom handlers. And we've seen how to integrate the Swagger/Open API testing interface and documentation tool into our service, which gave us a great way to both document and test our custom REST endpoints that we've added to our service. As I said, next time we will continue. We'll do a couple of other service endpoints, but we'll also begin to add a user interface into our service. So we're getting to the point where we really want to begin to test some of these service endpoints and our OData services in the user interface layer. As you see, I've already added an app router, doing a little preparation for that. I haven't shown that in the videos yet, haven't really added any content to it, but we will get into that in next week's episode. We are nearing the end. Our project is nearly complete. We could, of course, add more service endpoints, but we're to the point where there's just a couple more types that I want to show you, and then we want to build user interfaces, first very simple ones, but I want to show you also how to build Fiori UIs that take advantage of the annotations. That gives you some idea of what we have in store for us over the next 2 to 3 weeks. And then that will likely wrap up the series as we've pretty much recreated this entire application, full stack application end to end. So thanks again for joining us, and I look forward to seeing many of you back here next week as we continue to add a couple more custom endpoints to our cloud application programming model service.